Hello guys, today we are going to discuss a new topic, properties of triangles. This chapter has a better weightage in JEE Advanced. It's one of the most important topics regarding Advanced. So in this chapter we are going to discuss sine rule, cosine rule, some tangents formulae, and half angle formulas. And importantly, we'll discuss centers and circles connected to triangles, like orthocenter, and in this we will discuss about triangle, and there's all kind of stuff. And we're gonna discuss in center and discuss the in radius formulas and circle and all, and we shall discuss x-center, what is x-center, and x radiuses of x circles, and discuss about x triangle and about centroid, lengths of medians, and some more. So these are the topics to be covered in this video, right? Or in this chapter, right? Okay. So we will cover these topics and some more additional topics. So I'm gonna cover as soon as and also as detailed as possible. Okay, let us start with sine rule. Before, let us discuss the notations. What are the notations in a triangle, and what are the parts of a triangle? What in short we shall discuss. A triangle consists of three sides, right? And it has three vertices, right? Three vertices, and three angles are formed with the three sides of the triangle. So in general, those angles are denoted in capital letters as capital A, B, C, and side opposite to angle A is denoted as small a, and similarly the side opposite to angle B is small b and small c, sides of the triangle, right? And if all the three angles are acute, then it is known as acute angle triangle, and if any one of the angles is obtuse, then it is known as obtuse angle triangle. And if any one angle is equal to 90 degrees, then it is known as right angle triangle. I think you know it. Let us begin with sine rule. Okay. Sine rule tells that if R is circumradius of the triangle, if R is circumradius of the triangle, then A by sin A equal to B by sin B equal to C by sin C equal to 2R. This is sine rule. This is the formula of sine rule. Let us try to prove, right? I think we are aware of what is circumradius. Circumradius is the radius of the circumcircle of the triangle. Circumcircle is the circle touching all the three vertices of the triangle. In this case, like this, some circle like this will be the circumcircle of the triangle, right? Let's try to prove sine rule. Okay, let's prove in three cases. Let us take an acute angle triangle and try to prove the sine rule, right? Okay, acute angle triangle, let it be acute angle triangle. Okay. Okay, and let us try to draw the diameter. I think it is becoming blur. Okay, as all the angles are acute, so these all angles will be in the major segment of this chord. This angle will be in the major segment of this chord, and this angle is acute. So for this chord, this angle is in major segment, and for this chord, this angle is in major segment. So for this chord, circle lies to this side, center lies in this side, and for this chord in this side, and for this chord in this side. So center lies somewhere here, so the diameter will be from the middle of the triangle, the middle of the vertex. So let it be D. So as it is diameter, this angle would be 90, right? So let it be D, angle D. So in this right angle triangle, let us try to find sine D, right? Sine D equal to the side opposite to vertex. Angle B is B, it is C, it is A, and sine D equal to perpendicular by hypotenuse. So B by hypotenuse is nothing but diameter, so it's 2R, right? And we can see that angle D equal to B, as this is a chord and these two angles lie in the same segment of the chord. So we can write it as sine B equal to B by 2R. And similarly, joining B and D, it is 90, right? And if we try to let's it be d dash, let it be d dash. We can try to prove that sine c, right? Angle d dash will be equal to c, and d dash equal to c by 2r, and similarly we can prove sine c equal to c by 2r. And if we draw another diameter joining B and center, we can prove sine A equal to A by 2r. So we can write 2r as A by sine A equal to B by sine B equal to C by sine C, right? This is sine rule in acute angle triangle. And when we come to obtuse angle triangle, let's try to prove. This is an obtuse angle triangle, and this is somewhat some circle, as it is obtuse angle. So for this chord, this angle is lying in minor segment, so the center will be somewhere here. So this would be the diameter, and let it be d, and let's join. If it is the diameter, the angle, I think it is not that realistic that it is 90 degrees, but it will be 90 degrees as it is a diameter. So quadrilateral ABCD is a cyclic quadrilateral, so this angle will be 180 minus B, right? As a opposite angle, sum of the opposite angles in a cyclic quadrilateral is 180 degrees, so this will be 180 minus B. And in this right angle triangle, if we try to find sine 180 minus B, it is opposite B by hypotenuse 2r, and sine 180 minus B is nothing but sine B. So sine B equal to B by 2r. Similarly, we can prove sine A equal to A by 2r and sine C equal to C by 2r. So again, A by sine A equal to B by sine B equal to C by sine C equal to 2r, and it is proved in case of obtuse angle triangle. Let's get into right angle triangle. You can prove again. Alright. So try to draw a circle, as this angle is 90 degrees, so AC will be the diameter of that circle, so it will be 2r, and this angle is C, this angle is A, and we can write sine C equal to C by 2r, sine A equal to A by 2r, and sine B equal to sine 90, which is equal to 1. You can write as 2r by 2r, and here B equal to 2r. So in a right angle triangle also, we proved that A by sine A equal to B by sine B equal to C by sine C equal to 2r, and hence sine rule is proved, right? Let's get into cosine rule, right? Cosine rule states that formula of cosine rules. Cosine rules formula is a square equal to b square plus c square minus 2bc cos a. B square equal to c square plus a square minus 2ac cos b. Right, and similarly by this we can let b square, we can derive cos. So we can also write cos a, cos b and cos c formulas also by using cosine rule. So let's see the proof in case of acute angle triangle. Let's draw an altitude, let it be d, as this is b. In triangle ADB, finding cos b, which is BD by AB. AB is C, AC is B, BC is A. Well, now, so that implies that BD equal to AB cos B, which is equal to C cos B. BD is C cos B. And similarly, finding sin B equal to AD by AB, that implies that AD equal to AB sin B, AD equal to C sin B, right? Let us write an equation, right? AC square equal to AD square plus DC square, right? Pythagoras theorem in triangle, in right angle triangle ABC. And AD square is C square sin square B plus DC square is BC minus BD whole square. So C square sin square B plus BC square, BC is nothing but A square, BD is nothing but C cos B plus C square cos square B minus 2AC cos B. This AC square is nothing but B square, this will be C square, B square equal to C square plus A square minus 2AC cos B. Let us discuss in detail. So AC square equal to AD square plus DC square it is nothing but B square. So B square equal to C square plus A square minus 2AC cos B. Similarly, we can prove the other two, right? Yeah. Let us prove it in an obtuse angle triangle. In obtuse angle triangle, the altitude will be outside the triangle, let it be D. Similarly, it is B, but this will be 180 minus B. Finding cos 180 minus B in this small triangle, we get BD by AB, right? AB is nothing but C. Cos 180 minus B minus cos B. So this will be C cos B equal to BD, right? And similarly, if we write the Pythagoras theorem, in triangle ADC, AC square equal to AD square plus DC square, and AD square plus DC is nothing but BD plus BC. BC is A plus BD is minus C cos B, right? And it's square. AD square, AD, from Pythagoras theorem we can get sine 180 minus B equal to AD by C. It is C sine B plus A minus C cos B whole square. If we simplify, we get as above, like B square equal to C square plus A square minus 2CA cos B, right? And we can also prove it in right angle triangle. In right angle triangle B equal to 0, then it will be B square equal to C square plus A square, which is true and nothing but Pythagoras theorem, right? Let us discuss some more. Next subtopic is tangents formula rule. Okay, right? It's nothing but tan B minus C by 2 equal to B minus C by B plus C cot A by 2, and tan A minus B by 2 is equal to A minus B by A plus B cot C by 2, and it is also one of the useful formulae. It is nothing but it is derived from, we can prove it from sine rule, right? By putting B equal to 2R sine B and C equal to 2R sine C, we get sine B minus sine C by sine B plus sine C, and applying transformations, sine C minus sine D formula and sine C plus sine D formula, we can prove these all three formulas. It is quite simple. Let us jump into half angle formulas, right? Half angle formulas are also derived from cosine rule. We can prove it, we can deal with it. We know that cos A equal to 1 minus 2 sine square A by 2, right? And sine A by 2 sine square A by 2 equal to 1 minus cos A by 2, right? It's equal to half minus half of cos A. Into 1 minus b square plus c square minus a square by 2bc, half into 2bc minus b square minus c square plus a square by 2bc, right? Yeah, that's so yeah, it will be a square minus of b square plus c square minus 2bc by 2bc, half of a square minus of b minus c whole square by 2bc, which is equal to a minus of a square minus b square equal to a plus b into a minus b, right? So it is a plus b minus c into a minus b plus c by 4bc, but this is a plus b plus c minus 2c, that is 2s minus 2c into 2s minus 2b by 4bc, which is equal to s minus c into s minus b by bc. So sine square a by 2 equal to s minus b into s minus c by bc. So sine a by 2 is under root bc. Similarly, we can prove sine b by 2, sine c by 2, and using another formula of cos a 2 cos square a by 2 minus 1, we can prove cos a by 2 as root over s into s minus a by bc. And similarly, we can prove sin b by 2 cos b by 2 and cos a by 2, right? You can see these formulas, and we shall write down all the 6. Okay. Right, and we can get tan a by 2, tan b by 2, tan c by 2 by dividing sine and cos, right? Let us find tan a by 2. It is equal to sine a by 2 by cos a by 2, which is equal to right. Let's multiply by s into s minus a to both numerator and denominator. This will be delta square by s square into s minus a whole square. So it will be delta by s into s minus a, tan a by 2. Similarly, tan b by 2, delta by s into s minus b, delta by s into s minus c is tan c by 2, right? So almost we completed all the half angle formulas. Let's jump into circles in centers connected to triangle, right? Yeah. So let us first discuss about in center, right? In center is the point of concurrence of angular bisectors, right? Right. This is an angular bisector bisecting angle A into A by 2 and A by 2. So drawing 3 such angle bisectors, we get a point of concurrence that is nothing but in center. First, let us try to find the what is length of angular bisector. Okay, let it be length of angular bisector be beta through A. It's bisector through A. Let it be beta A. So let us find the beta A. How could we find it? Let us write area of triangle ABC equal to area of ABD plus area of ADC, right? Area of triangle ABC is nothing but half this C, it is B, half BC sin A, half BC sin A equal to ABD, half C beta A sin A by 2 plus half B beta A sin A by 2, right? So BC sin A equal to C beta A sin A by 2 plus B beta A sin A by 2 is equal to sin A by 2 in beta A into B plus C. It is BC into 2 sin A by 2 cos A by 2. So beta A equal to 2BC by B plus C cos A by 2. This is the formula for length of the bisector through A. Similarly, we can find the length of the bisector through B and C. So now let's jump into the topic. It is a triangle. This is one bisector. This is one angle bisector. This is one angle bisector. So this is in center I. So making this in center as center, actually, and drawing a perpendicular as radius, we can draw a circle. This is known as in circle, and the perpendicular is nothing but radius, and this radius is perpendicular to this tangent, which is nothing but side. The side will be the tangent. A circle will be drawn touching all the three sides, known as in circle, and the radius is known as in radius. This in radius is denoted by small r. So now let's find formula for small r, the length of in radius. So as this is in center, it will be in radius, which will be perpendicular to its, as side is tangent to the circle, three sides are tangent to the circle, radius will be perpendicular to the tangent, and this is r, this is r. Joining, we can form three triangles. Area of the triangle ABC, delta, can be written as sum of the three areas of the three triangles. And the area of the first one, half base of height into base is A, half AR plus half BR plus half CR. So it will be half r into a plus b plus c. It is half r into a plus b plus c is perimeter. It is 2 into semi-perimeter. It is 2s. So they replace that delta equal to rs and r equal to delta by s is one of the very important formula. And let's draw another diagram. It will be a bit more clarity. So this is in circle. So what is the length of C to, let it be D, let it be E, be F. What is this length? What is this length? What is this? Like how the in circle cuts the side. If in circle cuts the side, then touches the side, then what is the length of this portion, and then what is the length of this portion? Similarly for this side, what is the length of this portion? So tangents drawn from a circle to the circle from an external point are equal. So let it be x, then it will be x. If it is y, it is y. If it is z, it will be z. So x plus 2x plus 2y plus 2z is nothing but perimeter, which is 2s. So x plus y plus z equal to s. Since x plus y is b, the length of AC, since x plus y is b, z will be s minus b. It is s minus b. It is s minus b. Similarly, through C, the tangents drawn will be s minus c, s minus c. It will be s minus b is a, right? So it will be s minus a, s minus a. So in triangle ABC, if an incircle is drawn, the tangents from C will be s minus c, s minus c, s minus b, s minus b, s minus a, s minus a. This is somewhere in center, so this will be R. So as this is in center, this will be angular bisector, so this will be c by 2. In this right angle triangle, if we try to write tan of c by 2, tan of this angle c by 2, it will be equal to r by s minus c. So we can write r equal to s minus c tan c by 2. Similarly, if we consider this right angle triangle, we can prove tan b by 2 equal to r by s minus b. That implies that r equal to s minus b tan b by 2. Similarly, we can prove r equal to s minus a tan a by 2. So in total, we have r equal to delta by s equal to s minus a tan a by 2 equal to s minus b tan b by 2 equal to s minus c tan c by 2. These are all the formulas for in radius. You can also check mathematically. S minus a tan a by 2 is equal to s minus a into tan a by 2. From half angle formulas, we know that delta by s into s minus a. So this and this will be cancelled. It will be equal to delta by s, which is equal to, right? So these are all the formulas for in circle, related to in circle and in center and in radius. And this is the length of bisector drawn through vertex A. Beta A equal to 2bc by b plus c cos a by 2, right? Okay, so now let's discuss about the orthocenter, altitudes, pedal triangle and all. So what is orthocenter? Point of concurrence of altitudes, right? So point of concurrence of altitudes is nothing but orthocenter. Let us draw an altitude to triangle ABC. Let it be D. If it is C, it will be 90 minus C. If it is B, it will be 90 minus B, right? And if it is C, it is small b, it is small a. And from triangle ABD, we can find cos B equal to BD by AB. AB is nothing but C. BD equal to C cos. And similarly, in this right angle triangle, DC equal to B cos C. So A equal to B cos C plus C cos B. Similarly, if we draw these three altitudes, we get B equal to these are known as projection these are known as projection formulae. So by projection formulae, we can write the sides of the triangle A as B cos C plus C cos B, B equal to C cos A plus A cos C, and C so on, right? Let us get into length of the altitude and what is the length of the orthocenter, distance from orthocenter to the all the vertices, and we shall find all these things. This is a triangle A, B, C. This is an altitude, this is an altitude, this is an altitude, D, E, F, right? So okay, if it is 90 and it is B, it is 90 minus B, right? So and it is from the above, it is B cos C. So in this right angle triangle, if we try to find cos 90 minus B, orthocenter is generally denoted by letter H. So cos 90 minus B equal to B cos C by CH implies that it is sin B equal to B cos C by CH. Sin B is B by 2R equal to B cos C by CH. From sine rule, sin B is B by 2R. So CH equal to 2R cos C. Similarly, we can prove BH equal to 2R cos B. AH equal to 2R cos A. These are These are the distance from vertex A to orthocenter, vertex B to orthocenter, vertex C to orthocenter. These are the distances from the vertices to the orthocenter. Similarly, from this right angle triangle only, we can get the distance of the orthocenter from this side by calculating DH. We can apply sine in the same right angle triangle and we can get DH, EH and FH. These are the distances from orthocenter to the vertices, and these will be the distances of the orthocenter from the sides. We can calculate by considering those right angle triangles. Let us try to find the lengths of the altitude. How can we find the lengths of the altitude? Length of the altitude AD from the right angle triangle ABD, we can find this is B. Cos B equal to, let us find sin B equal to AD by AB. It is C. AD equal to C sin B, right, which is equal to half CA sin B by, and it is half, multiply by 2, and if we multiply by A, multiply by, divide by A. So it will be half CA sin B will be delta, it will be delta, so 2 delta by A. The length of the altitude through A is 2 delta by A, through B is 2 delta by B, through C is 2 delta by C. We can prove it. It's pretty simple, right? So let us get into what is pedal triangle and all. What is pedal triangle? Pedal triangle. You know, this is, here we got orthocenter and we got 3 altitudes. From this we can generate a pedal triangle. How we gonna see it? So the triangle joining the foot of the perpendiculars is known as pedal triangle. Pedal triangle is nothing but the triangle formed by joining the foot of the perpendiculars or the foot of the altitudes is known as pedal triangle. Let us try to find the angles and sides of pedal triangle, right? Yeah. ABC, right? So if we observe, this is orthocenter. If we observe this quadrilateral D, E, F, let it be the D, E, F. If we observe the quadrilateral DH, EC, opposite angles, the sum of the opposite angles is 180. So this quadrilateral is a cyclic quadrilateral. So a circle can be drawn through the vertices of this quadrilateral, right? So in this circle, this is a chord, and the angle here, this angle is equal to, as this is 90 in this triangle, as this is 90 and this is A, this is 90 minus A. So in this circle, as it is chord, and these two angles will be equal because angles in the same segment are equal. So as it is 90 minus a, this is also 90 minus a. Similarly, this quadrilateral BDHF is also a cyclic quadrilateral, and this is a chord as this angle is, as this is 90 and a 90 minus a, so this angle would be 90 minus a. I think you got it. I can tell it in a bit more clarity, right? This is a cyclic quadrilateral, so a circle can pass through it. In this cyclic quadrilateral, what I am telling is this angle and this angle are equal. As it is a circle, angles lying in the same segment should be equal. So as it is 90 minus a, this will be 90 minus a. Similarly on this side, this angle will be equal to, as this is a cyclic quadrilateral, this is a chord, this angle would be equal to this angle. This is 90 minus a, and this is, so the total angle here of the pedal triangle is 90 minus a plus 90 minus a. It would be 180 minus 2a. We write it as pi minus 2a. Similarly, this angle would be pi minus 2b. This angle will be pi minus 2c. So the angles of pedal triangle are pi minus 2a, pi minus 2b, pi minus 2c, right? And let us find the sides of the pedal triangle. This is the side of the pedal triangle, right? And we know this side, where is, this is the side of the pedal triangle. In this triangle, this is E and it is F. We know by projection formula, this is C and this is B cos A. This is B and this is C cos A. This is C cos A, is A cos C, total it is B, and it is B cos A cos B, and the total length of the total side will be small c, right? Considering this triangle AFE, this angle is A and the sides corresponding to this angle is B cos A and C cos A. By cosine rule, EF square equal to C square cos square A plus B square cos square A minus 2 into C cos A into B cos A, 2BC cos A. So C square cos square A plus B square cos square A minus 2BC cos cube A. If we take cos square A as common, B square plus C square minus 2BC cos A. So it will be cos square A into A square, EF square equal to cos square A into A square, EF equal to A cos A. This is one side of pedal triangle is A cos A. Similarly, the other two sides are B cos B and C cos C. So the sides of pedal triangle R, A cos A, B cos B, and C cos C. You can also write it as A is 2R sin A and cos A into cos A. 2 sin A cos A is sin 2A, right? So it will be R sin 2A. Similarly, R sin 2B. Similarly, R sin 2C. Sides of the pedal triangle can be written as A cos A, B cos B, C cos C, and R sin 2A, R sin 2B, R sin 2C, right? Yeah, these are the sides and angles of pedal triangle. And one more, if you try to see here, these altitudes are bisecting the pedal triangle. This angle is bisected by this altitude, right? This angle, similarly, this angle will be bisected by this altitude, and this angle is bisected by this altitude. It is bisected like 90 minus A, 90 minus A. Pi minus 2A is divided into 90 minus A, 90 minus A by this altitude. So, for this pedal triangle, these three altitudes are angular bisectors. And for this pedal triangle, this ortho center will be in center. So we can conclude that in center of pedal triangle is ortho center of triangle ABC. Ortho center of triangle ABC is in center of pedal triangle. This is a very important conclusion. Questions will be asked. And let us jump into X triangle, X centers, and X radii. Right? So let's get into the topic X centers. There are three X centers to the triangle. Firstly, what is X center? We should see what is X center. Right? In a triangle ABC, if we extend these two sides, there will be an exterior angle. The bisector of the interior angle of A and these exterior angles of the other two angles will be the point of concurrence of one internal bisector and two external bisectors is known as X center. This is X center. Similarly, three X centers can be drawn to the triangle by drawing three internal bisectors through three interior angles. So joining these three X centers, a triangle is formed that is known as X triangle. That is nothing but X triangle. This is just a rough one. We shall discuss in somewhat detailed. Right? Yes. Let's and one more. A circle can be drawn by taking this as center and drawing a perpendicular to any of these sides, and a circle can be drawn here. Similarly here and here. These are known as X circles. These x circles have a radius known as x radius. 3 x centers are denoted as I1, I2, I3, and 3 x centers have three circles known as x circles, and their radii are known as x radius, and we can draw a triangle joining 3 x centers known as x triangle, right? Yeah, let's find the length of x radius, and those x radius are denoted by r1, r2, r3, small r1, small r2, small r3, right? Yeah, let's discuss the formulas of r1, r2, r3. Right. This is I1 formed by joining as these three are internal bisectors. This is internal angular bisectors. This will be an incenter, which is point of congruence of angular bisectors. This will be an incenter, right? And yeah, this is a by 2, this is a by 2, this is b by 2, this is b by 2, right? This is c by 2, this is c by 2. As these are internal angular bisectors. This is 180 minus b, and its half is 90 minus b by 2. This is 180 minus c, and its half is 90 minus c by 2. Right? Fine. And perpendicular from this side, from center, x center to this side, is known as x radii. This is nothing but r1, right? Yeah. Similarly, this is also r1. So area of triangle ABC, I shall write it as area of triangle ABI1 plus area of triangle ABACI1 minus area of triangle BCI1, right? Area of this triangle is area of this triangle plus area of this triangle. I mean area of this total quadrilateral minus area of this triangle gives area of this triangle, right? So delta equal to area of triangle ABI1, hence it is obtuse angle triangle. Altitude is outside, height is outside, half height into base is AB. This is C plus half AC B into R1 minus half R1 into A. So half R1 into C plus B minus A. So half R1 equal into 2S minus 2A. So R1 into S minus C equal to delta, right? that implies that R1 equal to delta by S minus A. Similarly, we can prove R2 equal to delta by S minus B, R3 equal to delta by S minus C, right? And one more we shall discuss. This is B by 2, right? And this is 90 minus B by 2. So this is 90. And this is 90. This is C by 2. Let us discuss in detail. Right? Let it be I3, I2, I1, right? So as this is 180 minus B and it is bisector, this is 90 minus B by 2, 90 minus B by 2 bisects. And it is internal bisector, right? So this is B by 2. I am telling that the total is 90. This is the line. This total is 90. You can see it. Similarly here C by 2, this is 180 minus C and its half is 90 minus C by 2. This is 90. Similarly here this is 90 minus A, it will be 90 minus A by 2 and it is A by 2, it is 90. If you observe, for the triangle I1, I2 and I3, if you observe, this is an altitude and this is another altitude and this is another altitude, as these three angles are 90. So the point of concurrence of altitudes is orthocenter, but actually this is point of concurrence of internal bisectors of ABC. So the orthocenter of X triangle is the incenter of the triangle ABC. And one more, these are the altitudes, right? And this triangle ABC is connecting the foot of the altitudes. So triangle ABC is pedal triangle of its X triangle. Since it is a pedal triangle, its incenter is orthocenter of X triangle. So orthocenter of X triangle is incenter of pedal triangle. Here pedal triangle is ABC. So this triangle ABC is pedal triangle of triangle I1, I2, I3, which is known as X triangle, right? And we know the angles of the pedal triangle. How can we calculate the angles of the pedal triangle? Angles and sides of pedal triangle. So angles of pedal triangle is pi minus 2a. Pedal triangle angles. So pi minus 2 of this angle, pi minus 2 of this angle, 2 into angle I1, I2, I3 equal to angle B. So angle I1, I2, I3 equal to pi minus b by 2. It is pi by 2 minus b by 2, 90 minus b by 2. This angle is 90 minus b by 2. Similarly, I1, I3, I2, 90 minus c by 2, I2, I1, I3 is 90 minus a by 2. These are angles of X triangle. These are angles of X triangle. And we also can find the sides of the X triangle as like this. Actually, sides of the pedal triangle is A cos B. Here we know the side of the pedal triangle. It is A. It is obtained by I2, I3 cos it is I2, I3 into cos of I3, I1, I2 is 90 minus a by 2. A equal to I2, I3 into sine a by 2. 2r sine a by 2 cos a by 2 into 2 is equal to I2 sine I2, I3 sine a by 2. It implies that I2, I3 equal to 4r cos a by 2. So I2, I3 is 4r cos a by 2. Similarly, this will be 4r cos b by 2, 4r cos c by 2, right? Yeah. I think it is all. And these are some important points to remember. These are the sides of X triangle. Sides of X triangle. And let us try to find the circumradius of X triangle. Circumradius of X triangle. Actually, we miss it there. Let us try to find the circumradius of pedal triangle, right? What is the circumradius of this pedal triangle? We can find it. Simple. As we know the sides of the pedal triangle, A cos A, B cos B, C cos C, and 180 minus 2A, 180 minus 2B, 180 minus 2C. By sine rule, let the circumradius of pedal triangle be r dash A cos A by sine 180 minus 2A. So A cos A by sine 2A, which is A cos A by 2 sine A cos A. It implies that 4r dash equal to A by sine A, which is equal to 2 circumradius of original triangle, it is r, 2r. So r dash equal to r by 2. Circumradius of pedal triangle is half the circumradius of original triangle. So half of circumradius of triangle ABC. So pedal triangle's circumradius is half that of original triangle. So here the circumradius of X triangle will be half of its pedal triangle, and its pedal triangle is ABC. Its pedal triangle circumradius is r, So that circumradius of X triangle is double that of its pedal triangle. So it will be 2r. Circumradius of pedal triangle equal to half of original triangle, and original triangle circumradius is equal to double of. So here the original triangle is X triangle is the original triangle, and triangle ABC is the pedal triangle of X triangle. So the circumradius of X triangle is double the radius of triangle ABC, that is 2r. 2r is the circumradius of X triangle. So it will be like this. Triangle ABC there will be a pedal triangle for this, and X triangle and triangle ABC will be the pedal triangle of X triangle I1, I2, I3, and DEF is pedal triangle of ABC. ABC itself is pedal triangle of I1, I2, I3. Right? Hope you understand. And this radius is r by 2, this radius is r, and this radius is 2r. Right? And one more point is that this circumcircle of pedal triangle is nothing but 9-point circle, because it is passing through the 3 altitudes, 3 foot of the perpendiculars, so 9-point circle consists of foot of perpendiculars, foot of medians, and it also consists of the midpoint of AH, BH and CH. It is some other topic. I think it's not necessary, but you could keep it in mind that the circumcircle of pedal triangle is nothing but 9-point circle. Yeah. So and its radius also r by 2. And there is a relation between capital R and small r, that is small r equal to 4r sine A by 2 sine B by 2 sine C by 2. And also we are left with length of the median centroid related topics. So let's get into it. Before that, let's discuss a theorem known as Stewart's theorem. It is based on cosine rule. If a CN is drawn in a triangle of length P and it divides into M and N, then we shall derive Stewart's theorem. What is Stewart's theorem? States, let it be angle theta, this will be 180 minus theta. Let us find cos theta in triangle ADC. It is p square plus n square minus p square by 2pn. Cos 180 minus theta, which is equal to minus cos theta in triangle ABD, that will be equal to m square plus p square minus c square by 2mp. Right? That implies that minus cos theta equal to p square plus m square minus c 2p mp. Minus cos theta minus of p square plus n square minus p square by 2pn equal to p square plus m square minus c square by 2mp. 2p. We can write it as minus p square minus n square. right? Let us mn square plus m square n, right, plus np square plus mp square equal to b square m plus c square n, right? Once give a look. Yeah. And mn into m plus n plus p square into m plus n equal to b square m plus c square n. That is mn into m plus n is nothing but a plus p square into a equal to b square m plus c square n. That is a into p square plus mn equal to b square m plus c square n. When a C1 of length p divides the opposite side into two parts m and n, then this is known as Stewart's theorem. So now in centroid or in median case, m equal to n equal to a by 2, right? So we shall write it as a into p square plus a by 2 into a by 2 equal to b square plus c square into a by 2, plus that ap square plus a cube by 4 equal to b square plus c square into a by 2. That implies that p square plus a square by 4 equal to b square plus c square by 2. P square equal to b square by 2 plus c square by 2 minus a square by 4, right? This is 4 into 2b square plus 2c square minus a square. That implies that p equal to half root over 2b square plus 2c square minus a square. This is length of the median through a, as m and n are a by 2 and a by 2. If we take it as b by 2 and b by 2, similarly c by 2 and c by 2, we get all the three lengths of the medians. Let us name it as median through a, ma equal to half root over 2b square plus 2c square minus a square. Similarly, mb equal to half root over 2c square plus 2a square minus b square. Similarly, mc equal to half 2a square plus 2b square minus c square, right? These are the lengths of the medians of the triangle, and we know the centroid divides the median in the ratio 2:1. We had discussed the proof in our previous video. I will try to put the link in the description, right? I think that's all for today, and we have missed some topics. We may miss some topics. We'll try to cover as soon as possible in some other time, right? Thank you. Share this video to the ones for which this video will be useful. Please like, share and subscribe. Thank you.